Welcome to the 62nd lecture of digital electronics. So coming into the end of decoders, the last topic is BCD to 7-segment decoder. Okay, so coming into the lecture directly, BCD to 7-segment decoder. So, what is BCD? BCD means it is basically binary coded decimal. Binary coded decimal means you have values from 0 to 9 in decimal. That means from 0000 to 1001. Okay. Whereas the values from 10 to 15 in decimal, or 1010 to 1111 are considered as don't care. Okay. So binary coded decimal means the decimal numbers 0 and 9 are coded in binary. That means 0 to 9 are coded in binary. The binary equivalent of 0 is 0000 and binary equivalent of 9 is 1001. Now, what is now coming into 7-segment? Okay, so that is regarding binary coded decimal, first part. Now coming, next one is 7-segment display. Okay. What is done by 7-segment display? If you are looking into your calculators or in your computer systems or in your mobiles, you can see while representing a number, each number is represented using 7 segments. So I will draw that 7 segments or 7 LEDs, which is in the form of a segment format. So I am drawing it like A. You can see it is in the form of an 8. So I am just naming the LED, each segments as or each LEDs as A, B, C, D, E, F, G. Okay. So this is basically the form of a 7-segment display that we can see in your calculators. Now let me draw it once more. Okay. So let me just elaborate about this 7-segment display. So 7 segments, 1, 2, 3, 4, 5, 6 and 7. I am naming it the each segment or each LEDs as A, B, C, D, E, F and G. Now if I need to display the numbers from 0 to 9, which all LEDs should be glowing, that I will list here. So I will write the decimal numbers. Okay. And the segments needs to be glown. Segments which are high or which are logic high. Okay. Or instead of segments you can write it as LEDs which are logic high. So decimal numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So for 0, which all things should be on? A, B, C, D, E and F should be on. For displaying 1, only B and C needs to be on. For displaying 2, A, B, G, E and D. E and D should be on. To display 3, A, B, G, C and D. To display 4, should have F, G, B, C. That should be on. To display 5, which all should be on? A, F, G, C and D should be on. To display 6, which all should be on? A, F, E, D, C and G should be on. To display 7, so should be on. A, B and C should be on. To display 7, A, B and C should be on. Right? Okay. To display 8, you need to on all the things. So that is A, B, C, D, E, F and G should be on. And to display 9, which all should be on? To display 9, you have A, B, C, F and G. Yeah. A, B, C, F and G should be on. Okay. So these are the segments. These are the corresponding segments in which the range of segments which should glow to display numbers from 0 to 9. Now coming into different types of displays. So types of 7-segment display. Okay. 7-segment display. Basically, there are two types. One is common anode type. And second one is common cathode type. Okay. In common anode type, you have a VCC, control voltage, and you have these 7 segments just going out. So this is A, you can have, this is B, so you can have A, B, C, D, E, F and G. Okay. So in common anode type, what you have is when it will operate when VCC is greater than 0 volt. Okay. When VCC is greater than 0 volt, it will operate. Or you can say that or greater than 0.7 volt. That is the voltage required for the diode to get forward biased. Okay. That means each diodes will get forward biased. Depending on the condition. Okay. That means here the current flow is from VCC to ABC or ABCD EFG. Now coming to common cathode type. In common cathode type you have A. Okay, so you have A here, A, B, C, D, E, F and G. Okay, these strings are grounded. These all are grounded. Okay, that means here depending on the now if voltage at A is high, if voltage at A is greater than ground, then diode D1 will get forward biased. If voltage at B is greater than the ground voltage, then diode D2 will get forward biased. Similarly, you will get D3, D4, D5, D6 and D7. Okay, now in this case what happens is that this will get forward biased only if the VCC is greater than, or if VCC is greater than 0.5, and that too depends on the biasing characteristics of AB, the diodes D1, D2, D3 etc. Okay, here what happens is that when A is coming in, D1 will get forward biased, when B is coming in, D2 will get forward biased, and in that way. Okay. Now, in common anode type, here the low voltage is applied to cathodes, that is negative terminals. Okay, low voltage is applied to negative terminals. That means here what happens is that this is a negative terminal, right? This is a negative terminal. Okay, and compared to VCC, low voltage is applied. But here what happens? high voltage is applied at negative terminals. High voltage is applied at, sorry, not negative terminals, at positive terminals. High voltage is applied at positive terminals. That happens in common cathode type display. Now coming into this one. Now coming into the truth table of 7-segment display. Okay. So nice truth table. Truth table of BCD to 7-segment decoder. Truth table of BCD to 7-segment decoder. Okay. So first I will take the decimal digit. Okay. Then what we have is the corresponding BCD code. Okay. That BCD code has 4 bits. So let it be A3, A2, A1, A0. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So let me complete that drawing. This 1, 2, 3, 4, 5, 6, 7. Oh, wait. There's some problem here. Yeah. Let me do it once more. Three, 4, 5, 6, 7, 8 and 9. That's right. Now coming into 7-segment code. Coming into 7-segment code. So let me draw that 7 segments here. Okay. A, B, C, D, E, F and G. So here we have A, B, C, D, E, F and last is G. So you can stop here. Okay, that is already table. Okay. So here we have 1, 2, 3, 4. 0, 0, 0, 0. Yeah, 8 zeros, right? And last is 1. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0. Right? Wait 1 second, there is a mistake. There was a mistake in my writing. Just pardon me. Okay. So just rewrite first. So 4 is here. 5. Okay. So let me rub that first. One second. There was an entire mistake which happened. Okay. Let me clear it first. Now after that we will delete it shortly. There was a mistake happened. Sorry for the mistake. Okay. Now let me take it like this. Decimal number here. Okay. Okay. Now coming into decimal numbers. Which are decimal numbers we are having? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now write the corresponding BCD code. In that BCD code what we have is A3, A2, A1, A0. So 0 is there. Okay. 0, 0, 0, 0, 1. In 1 what we have 0, 0, 0, 1. In 2 what we have 0, 0, 1, 0. In 3 what we have 0, 0, 1 and 1. At 4 we have 0, 1, 0, 0. At 5 0, 1, 0, 1. At 6 you have 0, 1, 1, 0. At 7 the value is 0, 1, 1, 1. At 8 the value is 1, 0, 0, 0. At 9 the corresponding value is 1, 0, 0, 1. So that is therefore A3, this A3, A2, A1 and A0. Okay. So that is the corresponding BCD code. Next comes the 7-segment display. Next comes the 7-segment display. So here what we have is A, B, C, D, E, F and G. Let's here this D, E, F and G. So let me draw that 7-segment display here. So this is A, B, C, D, sorry, this is C, D, E, F and G. And if you want to display 0, which all things should be on? If you need to display one second. Let me redraw it once more. This is the basic 7-segment display. So you need to have A, B, C, D, E, F and G. Now to display 0, which all should be on? A should be on. A, B, C, D, E, F. A, B, C, D, E and F should be on and G should be 0. To display 1, only B and C should be on. To display 2, A should be on, B should be on, G should be on, E should be on and D should be on. Okay. Now to display 3, A, B, C, D, G. A, B, C, D, G. Now display 4, F, G, B, C. Okay. And to display 5, A, F, G, C, D. A, F, G, C, D. A, F, G, C and D. C and D should be on. Okay. Now coming into 6. 6 means you should have. Okay. So 6 means F should be on. F should be on. G should be on. Then ECD. E, C, and D should be on. Okay. Now coming to 7, you have A, B, C is on. A, B, C is on. To display 8, all are on. Okay. To display 9, what is on? Which all are on? A is on. A, B, G, F is on. A, B, G, F is on, along with C. Okay. And all other elements are not blown at this time. Yeah. So here you have 0, 0, 0, 0, 0, 0. All other elements is remaining as so. Okay. So this is how the corresponding decimal number BCD code and 7 segment display will get on. Now here what we need to have is we need to get expression for A. Okay, we need to get expression for A. That is our only intention. Okay. Now how to get this expression for A? Okay. If you are looking in the truth table, you can see that A is equal to sigma m. Sure things. A is equal to sigma m 0, 2, 3, 5, 7, 8, 9. 0, 2, 3, 4, 5. A is, yeah, 1 second. To display 4, A is not required. Okay. To display 3 is A is required. To display 2, A is required. To display 4, A is not required. To display 5, A is required. To display 6. Okay, 6 also we can have 1, no problem. To display 6, you can have 1 here, no problem. Okay. To display 6 also we can have 1. Okay. Now to display 7 should be there, 8 should be there, 9 should be there. Okay. That means to display 4 and to display 1, that is not required. Therefore we can write A is equal to sigma m 0, 2, 3, yeah, 0, 2, 3, then 5 to 9. This 0, 2, 3, 5, 6, 7, 8, 9. So that is A. Now if I am writing the expression of A like this, which one is don't care? Don't care comes from this one 10 to 15, right? 10 to 15 is giving us don't care. So D is don't care, sigma don't care. 10, 11, 12, 13, 14 and 15. Okay. Now if I am writing the expression for B, D is remaining the same for all. And if I am writing the expression for B, I can write it as sigma m, which all things. B is equal to sigma m, only 5 and 6 is excluded. All other things are there. That means 0, 1, 2, 3, 4, 5, 6 is excluded, 7, 8 and 9. Don't care remains the same. If I am writing the expression for C means only 2 is excluded. All other things are there. That means sigma m 0, 1, 2 is not there, 3, 4, 5, 6, 7, 8 and 9. What is D? D I can write it as sigma m. D which is excluded 1, 4 and 7 is excluded. 1, 4 and 7 is excluded. So 0, 2, 3, 4, 5, 6, 7 is excluded. That is 8 and 9. Okay. D is there. And now coming into that is D. Okay, so this I can write it as 5. No D. So write it as 5. That is don't care. Okay. CD. Now coming to E. Which all things are not there? 1 is not 1, 4 and 7 is not there. This sigma m 0, 1, 4 and 7. So 0, 1, 2, 3, 4, 5, 6, 7 is not there. So that is E. E. Now coming to F. F is equal to sigma M. F is equal to sigma M. What is there? Now it is no. Okay. So here also you have 0, 0. So which are not there? 1, 2. I will write in blue. I will write it in blue. 0. I will write it in blue. Okay. To have F, which all are not there? Which all are there? 0, 4, 5, 6, 8, 9. 0, 4, 5, 6, 7, 8 and 9 are there. Okay. Now here also you are having 0. Oh, okay. For D is 9 is not there. For D that you can exclude 9. So I have taken that. For D you can exclude 9. Okay. For D you can exclude 9. E, F, G. G you can write as sigma M. Which all things are there? 2, 3, 4, 5, 6, 8, 9. 2, 3, 4, 5, 6, 8 and 9. So that is G. Now suppose if we need to form an expression for A. So what is A? A means you have to add this don't care. So if I am having a K-map for A, I will show that example of A only, because then no need to form the entire expression for all these things. So you are having like this 1, 2, 3. Okay. So here I am. What are the inputs I am having? I am having A3, A2, A1, A0. This is A3, A2, A1 and A0. I am finding the expression of small a. 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now A is at 0, 2, 3, 5, 6, 7, 8, 9. 8 and 9. Okay. And don't guess are 10. Coming into don't guess. Don't guess are 10, 11, 12, 13, 14 and 15. Now if we need to derive the expression of A, it is pretty easy. Okay. So I will write the terms here. This is A3 bar, A2 bar. This A3 bar, A2. Here you have A3, A2. A3, A2 bar. Then this is A1 bar, A0 bar. A1 bar, A0. A1, A0. A1, A0 bar. Now let me take the possible combinations. Okay. So coming into first one. First one is I can take an octet here. I can take an octet here directly. Okay. So which is common? Only A1 is common. So here we have A1. Now can I take quad? Yeah. Yes, I can take quad. How I can take quad? I can take a quad here. To include that, I can take a quad. So what is the source for that quad? Which is common. Here A2 is common. Here which is common? Okay, here A2 is common. Now in that, here which is common? Yeah, here which is common? We can have what? Here A2 is common. Here A1 bar is common. So A2, A1 bar. Now you can take to include this. Okay, to include this one, you can go for this quad, no problem. So we're going for this biggest quad. What will we get? Which is already common. A3 is common. Now to include this one, you can have another quad. That is 1, 2. You can take from the corners. 3, 4. So which is common here? Which is common? A2 bar is common. A2 bar is common. A2 bar and A0 bar. Okay. Therefore, we can write the expression for A as A1 or A3 or A2 A1 bar or A2 bar A0 bar. Similarly, you can form expressions for A, B, C, D, E, F, and G. Now, if I am drawing a simple circuit for this, okay, so I am not going to derive the expression for A, B, C, D, E, F, and G, everything that you can do by yourself. Now, if you are drawing a very simple circuit, I will draw it using a block diagram. So here you are having BCD to 7-segment decoder. BCD to 7-segment decoder. And how many inputs? A3, A2, A1 and A0. There are 4 inputs and 8 outputs are there. The outputs are A, B, C, D, E, F and G. And each one is connected to the corresponding segments. So you can write A, B, C, D, E, F and G. A is connected to the segment, B is connected to B, C is connected to C, okay. D is connected to D itself, E is connected to E, F is connected to F, G is connected to G. Okay. So here you are having a combination circuit. You are having a combinational circuit. Okay. In that combination circuit, we have expressions for A, B, C, D, E, F, and G. Okay. So with that, I am ending with a lecture on BCD to 7-segment display. So we have started with the BCD to 7-segment display. What is it? And what is a BCD? What is a 7-segment display? And in 7-segment display, how it is flowing, and what are different types of 7-segment display. We have dealt with common anode and common cathode types. Then we have dealt with how it is operating. Then after that, I have derived the expression for A, B, C, D, E, F, and G. Along with the don't care, we can find the answers. And I have drawn a simple circuit. Okay, that is, it is basically in block diagram form. Okay, I have just shown in block diagram form. This is B is not connected. Okay. Okay, so that is all with the BCD to 7-segment display. Thank you.